Now, any question, the only dumb question is one you don't answer. You may ask a question, or you may have it in your mind, and you're afraid to ask it. Well, if you ask it, maybe somebody else is afraid to ask it. So there are no stupid questions you're afraid to answer.
And somebody that's been here a little bit longer has probably experienced something that someone that hasn't been here very long doesn't want to ask. So
basic information. I'll run through this fairly quickly, but this will give you just a working knowledge of the basics of valves and pipelines and how valves work, but also nomenclature about valves. Okay? So if you talk to people about them, you'll understand what needs to be done with that. What is a valve? Let's talk about a valve. A valve is any device that stops, starts, or changes the direction or magnitude of any flow or pressure. I know that's a mouthful. That's an engineering term. Some of you in here, of course, are engineers. But what it does is you have a piece of pipe and you have things that flow through it. I always like to use the analogy of a garden hose. You turn on your garden hose at home and you got water that's going through there. Well, guess what you have at the end of that water hose? Your little thing you squirt water with. That's a valve. So it gives you an idea of something you can control flow with. And that's what we're doing. Start, stop, or change the magnitude of the flow. And how do we do that? Again, with just the closure. The element in there that moves, that actually will control the flow of the media that goes through the valve. We talk about basics. Valves come in pressure classes. Some of you may be familiar with that. We'll start with what we call a class 150. If you see 150 with the, I want to blank here, the little symbol at the end here, I'm sorry. Yeah. Normally you'll see that when people talk about valves. If you read a valve spec or an RFQ or somebody sends out a valve spec, they'll always tell us class. And what that designates, and this is a standard throughout the industry. This is not just our valves, this would be anybody's valves. If you see the valve as a class, there's a maximum pressure. They call it MAOP, maximum absolute operating pressure, that the valve is to be used at and comfortable with. So you've got 150 through 2500 here. And you can see the maximum pressure. I'm not going to bore you with tears and read all this. You guys can read it, I hope. So if you know, what we've got there, the 800 class, you don't see very much anymore. You'll notice it's an interpolated, but there used to also be a class 400. If you ever see out in the field, you may run across some older valves from the 50s and 60s. All of this was pretty much ran forward, and the ANSI, American National Standards Institute, these were all adopted in the 70s. So you don't see much of this questions anymore. Most everybody's used to working with this. It's been close to 50 years now. So that's the way it works. But remember too, these pressures are not absolute. These pressures are at what we call ambient temperature. Ambient temperature, anybody know what ambient temperature, how that's measured? What is it? Anybody remember from your engineering training? I'm sorry?
The temperature of the environment.
Correct. Basic temperature of the environment. And we can talk about pretty much what that is. Minus 20 to plus 100 is considered to be ambient temperature. That's the temperature of the atmosphere, pretty much. So if we look at class, let's take class 600, pretty popular valve pressure that we use in pipelines. You know, when we look at class 600 here, and we go back to the ambient temperature, you notice the pressure rating is 1480. But what happens when things start to warm up and the valve is exposed to higher temperatures? Okay, if you'll notice your pressure rating, we get up to 500 degrees. The pressure rating drops to 1200. Why do you think that is? Anybody? What happens to metal when you heat it up? Right, it starts to get soft. It starts to soften. It loses some of its integrity. Now, it may not be enough to change the structure of it, but it does lose some of its pressure holding capabilities. If you're ever involved with a situation, this a lot of times we'll see in pipelines near a compressor station or a pumping station. Because what happens is as the pressure is increased, or the liquid temperature of the liquid pressure is increased through your pipeline, what will happen is it runs through the pump, well, there's heat transfer, and then the media starts to get warm. So you have to take that into consideration. Also inside of a building, if you're inside somewhere where temperatures may be different. So it's just something to think about. We've got it for every pressure class. And this is available. I mean, if you take that same 600 class valve and we get it to 1,000 degrees, look how much pressure it can hold.
Can I ask a question? just real quick. So, are you all focused on, we talked briefly last week, are you all focused predominantly on pipeline? Oh, okay, so you have wellhead. Anybody on the gas side where you deal with processing or anything like that? Okay, so in gas, one of my 9 lives as a valve cat person, you know, you get into gas processing and you're going through a mole sieve bed where you're drying the gas to get it to sales grade to put it into those dry through molecular sieve dryers anywhere from 500 to 600 degrees Fahrenheit. Generally ANSI 600 class valves, and you're trying to hold, you know, you're trying to hold that pressure in, so you isolate that bed so you can dry it out and run more gas. So yeah, if you aren't exposed to it, you know, talking about ANSI, you know, this may be very, very rudimentary, but we're talking about ANSI standards here. You know, that these classifications of 150, 300, 600, 900, and they're associated with pressures. If you ever get upstream to the wellhead,
6A.
you may not be talking about ANSI standards.
No.
You're talking about 6A pressure
6A.
standard, and those are, that's much easier in the sense, not easier to do, but in the sense that a 10,000-pound valve is going to hold how much pressure? It's pretty simple. This is just a little bit more confusing, but so I understand exactly what we're doing, and that's why I would ask the question of where you're all from. Are you just pipeline? But even after this, if you go into a different area, this expands, but there are different, you know, the 6A has the 1,000, 3,000, 5,000, 10,000, 15,000. So there are different standards. Go ahead.
Right.
So,
Right. Again,
So
look
just
at
to
your
kind of,
standards.
make a reference, so according like to the pressure class, so you mentioned like a regeneration there.
Right.
At 600 degrees.
Right.
So there's a correlation between like, is there a correlation between like temperature and pressure? Because at 600 degrees, higher temperature, then if you're using like a 600 class of pound ANSI valve, what's the correlation there?
what's the correlation?
Between like temperature and pressure?
Well, obviously, it's the same. It's going to be the same correlation in the sense that if you use an ANSI 600 class valve in a dryer application that's rated, your dryer, excuse me, your maximum temperature in your dryer beds is, let's say, 600 psi. Excuse me, it's 600 Fahrenheit. Your pressures through that dryer bed are going to have to be much lower. You're going to have to manage your pressures knowing that your temperature is that rate. You're going to have to manage that knowing that your equipment is limited to this, right? Here's your box you have to live in. If you want to dry it at a higher temperature or a higher pressure, then you size that up and you put that dryer bed in an ANSI 900 class, which is not uncommon. You know, the most common is 600 class, but you manage the equipment according to what your end results are. I don't know if that answered your question or not, but you know, the pressure temperature, you know,
Yes,
we don't change the laws of physics, you know, we just work around them. And in the sense that you know that at 600 degrees Fahrenheit, a 600 class valve is at 1,095, that's your box you have to live in. Now, if you want to go to a higher temperature and it doesn't contain it, you size it up to 900 class. Okay. And
One of the things that they're speaking to, you notice the pound sign behind each one of them. That's how you see it written. That's how they refer to the ANSI class valve.
so the temperature at 600 degrees Fahrenheit, if you're using if you want to run higher pressures, there's your 900 max temperature at 600 degrees Fahrenheit.
But I think he was talking more about the 6A valves is the
Oh, correlation
scale.
between 6A and ANSI?
Yeah, and as you
No,
increase pressure.
okay. Yes, just the ANSI.
Just-
Okay, right.
Yeah, on the 6A valves though, when you say you're using a 10,000 6A valve,
Yes.
and you go to the higher temps, you're already close to the limit on the 6A valve at 10,000. Do you therefore step that one up to the 15,000?
It's going to be the same.
Same correlation.
It's same correlation. We don't change the laws of physics.
You know, the metals are the same in a lot of cases, or you go to a different, you know, what determines that is your metals, your metals that are in there, and of course they also have ANSI flanges in a 600 class 20-inch flange.
You see this right here? This is what he's talking about.
Yeah, okay.
This is predicated on this line. ANSI B1634 WCB. WCC will be a little bit different.
Yeah.
If you go into, if you use a stainless, it's going to be, this is going to change. If you use a super duplex, this is going to change.
If you use a polyurethane valve, it's going to change.
Yeah.
Peanut butter, it's going to change.
Yeah, there's a,
So are you talking about just the material of the ball itself?
No,
Just
body, pressure,
body. Okay.
Pressure containing vessel.
pressure containing vessel,
Yeah.
okay?
Yeah,
But
that's your key.
just one, the 600 class, everybody refers to it as 600 class. When you're exchanging data with people, oftentimes that gets confused. Somebody will say, well, I've got 600 pounds. Okay, then it starts sounding like, okay, well, that's your operating pressure, your media pressure inside. So when you're referring to a lot of this stuff, refer to the class, not necessarily the pound.
Right.
ANSI standard, again, American National Standards Institute, B1634. This is your standard, and this is in the industry. So if you buy a 600-pound class valve from us, from anybody else, they're all the same standard. Okay, that's how it is. So the industry decided in the 70s again to standardize on this, but you move into a different valve with different material. Again, the WCB is steel, okay, which would be a standard valve range here. The WCC would be a low temperature, probably go to -50, but then your maximum pressure rating is also derated. So pay attention to the specifications on the valve, but it depends on your project and your application. That's going to be your key for doing it that way. Any other questions? Everybody good with that? Okay, moving forward. Let's talk about castings. Okay, we're going to talk about the two basic components of valves, which one is casting, the second one is forgings. Okay, castings are very simple. I know this sounds confusing, but what you do with castings is you take a lot of times people today use scrap metal, you know, recycled metal or other types of metal, and they melt it and they pour it into a form, and it allows the material to take the shape that you particularly want it. And they'll show what they call as a core or a mold at the top center. And then they put the molds together, they melt the material, pour it in. Then after it comes out, they clean it, blast it, grind it, heat treat it. They'll machine it, do whatever, check it, make sure everything's done for that. So that's a casting. And it's an inexpensive way to make valves, quite frankly. Castings have been around for probably over 700 or 800 years. If you've ever seen the old movies where they're making swords, you know, they'll pour the molten material in kind of an open type form, and it takes that shape. Castings have been around forever. Castings have the advantage of being less expensive. There's two issues with castings, which we'll talk about. Number one is brittleness, and number two is porosity, which means that the media that's inside that can get out in particular cases. Now you can fix that, but I can lay a casting here on the floor. If I take a big enough hammer and hit it hard enough, it'll crack, maybe it will break. So that's one of the downsides of the casting is, depending on your application, there's a certain amount of brittleness. But they're a less expensive way to make valves. And every valve manufacturer uses castings in one form or another to make valves. We talk about forgings, and this shows a press and shows this molten piece of material that's held in there. I'll give you guys the easiest example of a forging. How many of you have ever seen in person or seen in a movie how they make horseshoes? Stick them in the fire, get them cherry red, lay them on the anvil, and take a hammer. Whang, whang, whang. That's how they're making horseshoes. Quite frankly, it's a very simple way to talk about forging. That's how forgings are made. The material gets into a semi-liquid state. It's melted to where it can be shaped, kind of like putty. And then it's usually pounded into a form or into a particular shape. And they use presses, sometimes hydraulic, sometimes what they call hammers. They bring a ram up to the top and release it, and it goes bam! If you've ever been into a forging shop, they're hot, noisy, and something else to look at. But this is an example of a forging. The plus side to a forging, think about what I said about casting. As material pours into a mold, it finds the spots to fill in. The molecules, when they cool, randomly line up. Okay, within the, if you can see it under a microscope, and the grain of the material, it kind of runs in all different directions. What happens is that you don't get a toughness. That's why they're brittle. they'll break because the molecules do not bond and form in a what we call a very hard or tough form. Secondly, when these molecules line up, if you have some type of impurity in there, grains of sand or whatever else, that also sets in there and the material doesn't fill that in, and then you have a little hole that goes through there. Some of you may have been involved where you actually see a casting that'll actually leak through the body. Sometimes that happens. We can repair that, we weld it, but it's an issue that goes out there. Forgings, what happens is when you're applying a pressure to the material, it forces the molecules to line up in a particular direction. They bond more securely. You don't find leaks through the bodies of forged valves. It just doesn't do that because the pressure requires every bit of that voids inside the material to fill in. That's why today on most pipelines, especially natural gas, the requirement for interstate pipelines, and this is by the Department of Transportation, is for forged valves. They want that, make sure that extra level of keeping that material inside the pipeline. Okay, so that's the difference between castings and forgings. They're cheaper, but we talk about porosity, brittle. Forgings cost more because I got to heat the material, I got to have other equipment to beat it up, you know, form and shape it. But we don't have porosity and no brittle issues. So a lot of times the difference between forgings and castings. Okay, questions on that? Run through that fairly quickly. Okay. Let's talk about groups of how they're grouped by how they close on the seat. The seat is the sealing area of the valve. So we have two different kinds of valves. We have what are called manually operated valves. Some type of outside influence, whether it's a hand or an operator that's put on the valve or a signal sent to the operator, something tells that valve to open and close. And then we have automatically opening valves, which are valves that don't require human intervention to actually open and close. Manually, you know, we've got globe valves, white pattern, and slide valves is wedge, slab, parallel slide gates. Kevin's going to talk about your wedge and gate valves today. Rotary valves, ball valves, plug valves, butterfly valves, and the flex body, which is normally used in valves that are for media that has a lot of solids in it. I've sold those actually to people in gravel pits when they wash gravel. So those things happen. But we don't normally deal with that in our particular industry. Automatic valves, or check valves, swing, tilting disc, ball check, non-slab, and the biggest one that you see is pressure relief valves. They don't require human intervention to work. They're designed to work automatic. Okay? So again, manual valves, automatic valves. Question? All right, moving on. A CV factor. Everybody know what CV factor is? Yes, no? Okay. CV, okay. Engineering terms. Coefficient of volume. Amount of gallons per minute of water, that's how a valve is rated, by water flow, flowing past the valve, required to create enough friction to lose 1 psi of pressure, which means pressure drop. Easy way to remember that is remember your squirter on the end of your garden hose? If you take that off, guess what you got? Turn the spigot on, you got a full flow of water, right? You put that, put your spigot back on there, and then you are moving your handle or either twisting something to open and close that. What you're doing is you're creating what's called a pressure drop. How many of you have ever had the opportunity, especially guys, washing a car and you couldn't find your thing that goes on the end of the hose, so you put a kink in the hose and hold it, right? What happens when you first start to open that? You get a lot of high pressure, right? And as you open that hose up, your pressure drops, but your volume increases. That's a restriction. So what we want to do is that we have flow here into a valve. This is like representative of a butterfly valve here. Anything that's in that flow path is going to slow down that flow through there. So what you measure is what we call pressure drop. You gauge here, and through your closure element, you see how much pressure drop that you have there. And we'll talk more about how that applies in valves, but CV factor. If I have a valve, and let's take this ball valve here. That's why we brought this easy to show. You can see through this ball valve, and this is the same diameter as a pipe, right? So how much CV drop do I have through this valve when it's fully open? Anybody guess? What's my pressure drop on this valve? There's none, technically speaking, because when the valve's completely open, now of course when I partially close the valve, Now I'm creating a pressure drop. I'm restricting flow. So what would be the CV factor on this valve when it's fully open? Anybody want to guess? Come on, remember your basic math.
Virtually none.
It's called 1. A perfect CV factor where no restriction of flow and no pressure drop is a CV factor of 1. Once I go here, start to close this valve, now my CV factor may be 0.85, 0.80. So again, CV factor is critical because if you're designing or working within a pipeline, you've got to put product in the front end of that pipeline, and you've got to be able to tell people what's going to come out the back end of that pipe. If I have a full open valve, same pressure I put in product should be the same I get out. Now there's a certain amount of pressure drop created, again, engineering basic, because when media flows through, especially liquids, this is not so much an issue in gas as it is, but it's more in liquids. The side walls of the pipe, where the liquid contacts the pipe, creates a certain amount of friction. So when your liquid goes through, you're going to get a certain amount of pressure drop, and that's engineered into your pipeline and all. Gas is normally not that big an issue because I don't have a liquid material that's a heavy material to push through there. For gas, it's basically negligible. You can't really measure. But liquids, it makes a problem. Because remember when your profile through your pipeline, yeah, here's a little bit, this is your pipeline. Because of your friction here, your flow profile looks like this, going through a pipeline with liquids, right? That's what you got to do. So when you measure flow in a pipeline and talk about your valves, where are you going to measure? You're not going to measure your flow here. You're going to measure your flow in the center. Okay? Basic to cover with that. But that's just basic engineering. So we talk about CV factor and how that CV factor works. It's critical when you're doing calculations, and also valves, because we have valves that are like this. This is called a full open valve. But you also can buy valves that the port through the ball in the center of the valve is actually smaller. Then you create your own pressure drop. In certain valves, we'll talk about plug valves today. Plug valves have a smaller opening through the valve than the pipe itself, so it creates this CV factor and pressure drop.
So, yep. The terms for that, that's a full port.
This is a full port or full open valve. If you have a reduced port, that's when the hole through the ball is actually smaller than the inlet and outlet side of the valve here. Okay? Uncommon types of valves. And this is a little bit of a misnomer. Gates and globes. We don't see too many globes, quite frankly, especially in pipelines. We do see gates, but gates is more liquids. I had designed this basically for gas, so my apology for that. We will talk about gate valves. The gate valves will be more into your liquid side. Okay, so uncommon. A gate valve, again, liquid service. The seat can be metal or resilient material. Usually more expensive than a ball valve, especially in the larger diameters. But sometimes that's what you use. Rising stem valve. I'll show you in another valve, another situation. This is the oldest design valve in history. We'll talk about that in just a few minutes. Rising stem valve, threaded stem. A lot of times your old manual valves had a hand wheel on like this out in the field. If you rode by it, you could see the valve. You see a bunch of threaded stems sticking up out of the top of the handle. Usually meant the valve was open, because as you screw that handle, it pulls the gate up out of the valve. If you went by and saw just a little bit of the threaded rod on top of that valve, usually meant the gate was closed. So a lot of times you can visually see those. Many turns open and closed. Sometimes they can be difficult to automate, mostly with electric actuators to do that. A bolted bonded globe valve. These are also used somewhat in liquid service. You may see these. Are you familiar with the faucet on the outside of your house where you turn the water off and on? That's what that is, believe it or not. Your material flows in this way. This is a resiliency or an O-ring. And what happens is you turn your spigot on the side. I'm sorry, I call it spigot. I'm just out here away. But you pull that. What you do is you pull this off, so your liquid starts to flow past the seat and then flow out of the valve. And when you look at your faucet on the outside of your house, that's what you have. This is also usually your kitchen faucet, especially if they had the old type. They had the two handles, one for hot water, one for cold. What you have is basic design. This valve design has been around for over 200 years. Pretty basic too. The The downside to this a lot of times is you continue to lock down the seat. Whatever this material is usually takes what we call a set. It starts to form into the seat. And then it starts to take a set, and you have to keep cranking it down a little tighter and a little tighter. And eventually your seat gets to the point it won't seal anymore, and then you got to replace it, or you got to replace the valve. But it's a pretty common valve with that. Okay. Swing checks. We see a lot of these with what's going on out here. With what we deal with, it's normally 2-inch to 36-inch in the API sizes, all the way up to class 600s. The nice thing about this particular check valve, this is your flow, and it has what we call a clapper right here. So as your flow goes in, if this flapper is at a slight angle, it pushes this flapper up and allows your flow to go through the valve. Well, what happens when the flow reverses? Your clapper comes down and closes off, and your material can only go one way. Pipelines, especially around pumping stations or compressor stations, real critical. If you have a pump that pumps things out one way, you don't want the material to start pushing that pump back the other way. That's how things get damaged. So what we do with the check valve is it's called a directional valve. It's a one-way flow. So you see those in pipelines quite a bit, whether it's gas or liquids.
That'll actually come in when I
Yeah.
talk later. There are directional valves, and the standards by which how to manufacture a valve is the API and ANSI standards. You know, it has to be this thick, the face has to be this long. Directional valves will have an arrow on them, meaning, I know it seems, I say that and it seems rudimentary. You'd be surprised how many times I went out there and they put check valves in the wrong direction.
Oh, yes.
I'm sorry. So it's just the case. Sometimes we get up on the wrong side of the bed and we're not thinking when we do something. But when I talk about our valves, there are directional valves where it is only one direction. There's also a term called bidirectional. We'll cover that in a minute, and I'll cover it. But there's also a thing called preferred pressure direction. And we'll explain that as well, okay? But there's a clear delineation. It's kind of like we were talking about a minute ago. This is a full-ported valve, right? Everybody knows what the term full port is. 12-inch pipe, 12-inch valve. There's a reduced port, or sometimes if you get inside a plant, reduced port is also used, the term synonymously called regular port. So it's like a 6-inch valve with a 4-inch center. But we talked about full port. Is anybody familiar with the term through conduit? Okay. I'll cover that in a minute.
Yeah. We'll come back to that. Gas side, but also liquids, you see a lot of ball valves. And this is a ball valve. And there's basic design, there's two types. First and foremost is what's called a floating ball valve. Usually this is smaller diameters, and the reason they call them floating is that there's a groove in the top of this, which attaches to the valve stem, but there's nothing on the bottom. The seats you see here and here are fixed in the valve. So when you close that valve, the ball actually travels a slight distance and moves into the seat and is pushed into the seat to create the seal. So the ball actually floats back and forth between the seats. Seats being fixed, the ball moves. Okay? That's a standard, and everybody calls them floating ball valves. You normally see these in small diameters, 2, 3, and 4 inch. It's rare you see much bigger than that, and you rarely see them above 300 class. You get to 600 class and larger, you don't see floating ball valves. People just don't use them. It's a very rare thing. But they're inexpensive. They're pretty cheap to make because the tolerances to allow for the seats and everything pretty wide open. Pretty easy to seal off the valve. It's fairly expensive to make. So a lot of people use them in lower pressure, smaller pipe diameters. Pretty weighted. The trunnion mounted ball valve is one of the preferreds in the pipeline. This is a trunnion mounted ball valve. We have a cutaway on this side of the valve. It's very simple to see. Well, take it apart and see it. It's a lot easier to do it that way. There is a bearing block and a bearing block, and we'll see one of these today over at our plant tour. We've got one taken apart so you can actually see it in more detail. But what happens is that instead of this ball floating around inside there, the ball is contained between the top and bottom trunnion mount. There's a hole through each one of these in a way that the ball is trapped. So the ball can never move. The ball pivots on an axis. If you draw a straight line from the bottom to the top of this valve in the center, the ball pivots on the axis. What happens though is the pressure related and the seats, which are these things inside the valve, have springs behind them. So the spring pressure pushes the seats on the ball. That's how that operates. And then the way that the way they're designed, and we'll show you this in a little more detail, what happens is your pressure also gets behind the seat, and as your pipeline pressure goes up, it pushes the seats even firmer up against the ball, which creates your seat. So the biggest difference between floating ball valve and trunnion ball valve, remember, on a floating ball valve, the seats are fixed and the ball moves. On a trunnion mounted ball valve, the ball is contained and really trapped, only pivots, but the seats move. The advantage to the trunnion mounted ball valve is because I support this ball at the bottom, I can make it as big as I want to make it. I'm not worried about on that floating ball valve, not only are you opening the valve against the flow rate, you're having to turn the mass of that ball, which is just floating around inside there. You can imagine how much that ball weighs when you get up into a 6, 8, 10-inch valve. The ball itself can sometimes weigh 300 or 400 pounds. On this valve, I don't care about weight. Because again, I've got the ball protected.
Right. And you throw in the added calculation. The difference in the floating ball valve and the trunnion ball valve, the advantage is in a floating ball valve, if you have that mass of metal, it's difficult to turn, but then you close it and add pressure at 600 psi, and you're trying to break that ball off of that seat, it becomes cost prohibitive. You can't buy a gear big enough, or an operator big enough, or you don't want to pay for it.
Because there's so much pressure
That
driving the ball
pressure
into the
driving the
seat.
ball to that downstream
Because it's
seat.
floating.
And the way you're going to learn is when you have been exposed to someone making a bad decision. How you doing? Captain Vincent? I learned the difference in trunnion and floating ball valves. I was part of a group that started our own company many years ago, and this is how I learned. We sold our first valve to Enbridge. It was in a gas processing facility, and we were putting an actuator on a 6-inch 600 valve for a reason I'm familiar with molecular sieve drying is because that's my background. Started many years ago with a little company called Orbit. Spent about 18 years with them. They kind of own that world. But we were building a competitive valve, and this 6-inch 600 and a floating, I was very familiar with what our torques were, and I put this together, and the engineer goes, well, probably want to do this, that, and the other. And I said, no, this will work, right? This will work. So we put that in there, and we added pressure, couldn't operate the valve. I screwed up, right? Went back to my design engineer, and he said, well, we need to make that a trunnion. The difference in the foot-pounds of torque required to turn a full-ported 6-inch 600. This was in this instance. This is not across the board, but it's a good example. 6-inch 600 floater, full-port at 600 degrees Fahrenheit, 1,000 psi, give or take, versus a trunnion. This was a third of the torque required, literally. So your actuator sizing went from 4 Dodge trucks to a Miata. I mean, it was just, put the valve in, worked beautifully, they started using them. But that's the advantage of when you add the pressure, mass is one thing, but when you add pressure, it's a whole different ballgame. So, sorry.
All right. So again, when I said in my earlier statement, in floating ball valves, you normally see them in lower pressures and smaller sizes. Again, larger valves, higher pressures. Quite frankly, I don't know that I have ever seen an actual in operation 600 class floating ball valve. It's rare. It's rare. But I mean, in your world, yeah.
Yeah, we come from different worlds. You go into a power plant, you go into we're talking about.
It's got 30s and 36 inch, and they can't take them out, so.
Yeah.
Anyway, there's a couple of customers who have some old Rockwell built, some 30 and 36 inch 600 class floating ball valves, and they have these, they're the largest actuators in the world that have to turn them because they're operating up at 600, they're operating up at about 800 psi.
Yeah.
there's so much pressure on these things, and they want to get them out, but they're critical valves. They have to shut their system down to do it.
Tell them good luck trying to find a replacement exactly like that.
Yeah, no,
I mean, look, as soon as, I'm one of those, I try not to be, it's never gonna happen, right? In every industry, there are exceptions, but there are companies out there that only build floating ball valves up to 2500 class because of the application. Because you can't build a a metal seated ball valve to get the seal that you need in severe service. There are companies like Mogus and Valve Technologies, and these people cut their teeth on stuff. What we do is simple. These people are running rocks and steam and, so there's exceptions to every rule. There are small niches in this industry, and yes, there are big metal-seated floating ball valves, again, but in that industry, you can't do what they do with their design with ours. Ours is soft seat, resilient seated. It's designed for up to 250 degrees Fahrenheit. These things go to 1400 F. It's different. So there are exceptions to every rule, but they're out there. But our world, your current world, that's a general guideline. What David is saying is right. Most of your floating ball valves are lower pressure, smaller diameter. It's more advantageous for you to look at a trend, and then you get to a certain size, certain pressure.
So if you use like a training ball valve for isolation, for instance,
Absolutely.
is there like a kind of a requirement for like a minimum differential pressure, like if you want to kind of go by the size? Because on one end there's zero pressure because you're using it for isolation.
Right.
Then on the other end there's energy.
Right.
So is there like a kind of like, so the differential pressure now is large because on one end it's zero and on one end. So is there like a required differential pressure, or can you just slowly open that training valve and go back to size?
In a trunnion ball valve, depending on your seating systems, the differential pressure is not that. The valve will operate, right? It's going to open.
It'll open.
You get enough energy on top of the actuator. The issues with opening against a high differential, especially in a resilient seated valve, is what's it going to do to your seating area, right? So I may not understand your question. In terms of opening that valve under that differential is going to be a policy that you do internally, right? Will the valve operate under it? Sure.
But there are considerations. I'm going to talk about plug valves next, and we'll show you how some people get around that, especially on large diameter valves that have a high pressure differential, 1,000 psi in atmosphere, and how they
do bypass,
open
right?
it back.
We do bypass to equalize.
Yeah, bypass is the
pressure.
biggest way to do that.
Right.
Yeah,
To charge a downstream line.
bypass is normally common, but
Right.
in some old plants, in which they don't have that 2-inch bypass
Right.
the valve,
Right.
so they have no other option but to kind of still operate.
To open that valve. Quite frankly, if you're going to open that valve with a very high differential and you don't have any other choice, do not slow that valve down. You want to get that valve from fully closed to fully open as quickly as possible. That's safe within the parameters of your system. Because the longer you sit there with that valve partially open, because what happens, again, when you partially open this valve, imagine when it's open, this entire seating area here, sorry about that, this entire seating area here is behind the ball, because the ball covers the entire seating arrangement. But if you open the valve partially, then you've got this, say if the ball is here and then the ball starts to open here, and this is your area that's exposed in the downstream seat, what happens is that rush of material starts to eat away and erode the seat. And the more you do
3 o'clock
that,
is going to be sacrificial.
yeah,
Right there, 3 o'clock on
Yeah.
that face of that seat.
And that's
So-
where I was getting.
Right.
Yeah.
Sacrificial element.
That's inherent in the design.
right. That happens with what's called erosion. In our nomenclature, erodes away the seat, because whatever material you're flowing through there, whether it's a gas or liquid or anything, there's a certain amount of abrasion that happens with that seat being exposed. So that's why in a lot of what we call control valves, where they modulate it and keep the pressure or the volume at a particular flow rate. Sometimes you won't find a resilient seat. You may find a harder seat, a metal seat or something like that can handle that quicker, or a lower flow rate. But again, in your situation, I would recommend from full close to full open, do that as quickly and as safely as possible, because you want to minimize how that seat is exposed to the flow stream. Does that make sense? Yeah, that's the easiest way to do that. Everybody understand what we were talking about? The bypass I'll show you. Sorry. The bypass I'll show you when we talk about plug valves. All right, one more time. When you have magnets put together, you got to make sure you put them back in the right place. We'll talk about that a little bit more with the plug valves when I get to that in the next presentation. Let's consideration and close out some things here on valves. Again, in the marketplace today, there are many different types of valves. We've talked about them. One of the biggest problems we see, not so much in pipeline, but like in process, if any area involved process and even in liquids, is get the right valve for the right application. Any valve will normally work in most applications, but is it the best valve for the best application? Are you going to get the most service out of the valve, the most reliability, and the best life? So make sure and choose the proper valves when you use that. Sizing, do you need a full port valve? Do you need a reduced port valve? Make sure that it fits. So sizing for the valve, and make sure it's the right pressure class valve to handle your flow and volume through your valve. Piggable, how many of you know what pigging means? Everybody know what pigging means? Okay. I have a question for you about pigging, and I've never been able to get a right answer. Do they call it a pig because it gets nasty, or because of the noise it makes when it goes through the pipeline?
Because it squeaks like a
Huh? Noise, yeah. Because it's saying, if you've ever been near a pipeline where you hear them, they squeal when they go by. You know, the scrapers catching all that. I thought it might have been because they got so nasty looking, whatever else. Again, is the valve for buried service? Because a lot of pipelines are buried, or is it above ground? That's a consideration for the valve too. We'll talk about that a little later. Coated or non-coated is the finish on the outside of the valve, because if you're going to bury this valve, you've got to have a certain coating on the outside of the valve. If it's above ground, I'll ride by. If it looks a little rough, we'll go out there and blast the paint off of it and repaint it, make it pretty again, right? So that's a consideration. Where's the valve located? Is it in a remote area, 5 miles from the nearest source of power, or is it inside a building at a compressor station? It makes a difference on the application of the valve. And bottom line you have is maintain all your valves. Make sure the valves, you get the best life and service out of any valve is maintained, okay? Get there, all right. Many types of valves are used in oil and gas. Use the right valve. It's more to the valve application than just cost. And at the end of the day, and I can give you countless examples, we're dealing with public safety here, guys. We don't cut corners, period. I could talk about San Bruno, for any of you that ever heard of that out in California. We can talk about the wildfires last year in California. The only time I can give you real quickly was I was working for another valve company, and I got a phone call at about 6 a.m. one morning. And this happened in eastern Tennessee, that they had a compressor station out there for natural gas, East Tennessee natural gas. At about 6 a.m., an F2 tornado went right through the middle of the compressor station. I mean, it just looked like it cut a path about 100 yards wide right through the center of the compressor station. You can imagine what that looked like, because they were calling us saying, how do we shut this thing down? They had to go find a valve that was 3 miles upstream from the compressor plant. It wasn't automated. Guy goes out there and with a gear operator on top of that valve, and 220 turns later, he got the gas shut off. But it happens. But again, can't control that. None of us can control weather and nature. But again, safety. Okay? Questions? Again, that was valve 101 where we just talked about basic things. Any questions?
I do have one.
Yes.
Typically use forge valves a lot in natural gas. Forge valves, it's a requirement?
Yes, pretty, in interstate pipelines.
So what's the largest sizes coming in? Maybe it's small sizes now?
In the United States, there is very, very small section of 48-inch valves. Majority of pipelines in the United States are either, they go from 24-inch to 42-inch. That's pretty standard. You'll see a lot of, a little bit of 20. Most of that is what we call laterals, which is, that goes off the main pipeline and goes out and feeds other areas. But 24 through 42 is probably 97% of pipelines in the U.S. Like I said, there's a very small part, larger, that's in the 48, but I doubt there's a few hundred miles.
A lot of those are headers, and a lot of those are loops, like they'll loop just for volume, but
yeah,
everything else is 42 and below.
Yeah, 42 and below is pretty much standard with it out there.
Interesting. I thought they were just smaller sizes, so instead of.
Well, and again, when you're getting into what we call laterals or gate stations, all of you know what a gate station is in a pipeline. You'll normally you'll see them along freeways, highways, interstates. You'll see a chain link fence around this area, and you see pipes come up out of the ground. It's usually where they put their instrumentation. They'll have a flow meter, they'll check different things, and you'll have a lot of little valves. You get down to 2-inch valves with a lot of those in some of the small areas. And around compressor stations or pumping stations, you'll find smaller diameter valves. I would guess if you had to talk about the volume of valves, 12 to 24 inch, we sell a lot.
Yeah.
That's pretty popular sizes, especially for laterals. And again, on laterals, anything comes off of a main pipeline. But yeah, that's probably the bulk of it. But again, up to 42 inch is pretty standard. We're starting to see a little more 48. Now you go overseas. At the factory, we represent Valve Italia, which is an Italian company. They have built 72-inch ball valves. These are used in the Middle East. I mean, you can literally walk through the valve. But these are, Middle East, other places like that. In the U.S., we don't use those larger pipelines, because you can imagine burying a 36-inch pipeline and then having to bury a 72-inch pipeline.
We just supplied most of the valves, the majority of the valves there's the Valley Crossing project, that's down in South Texas. That's a gas project. Yeah. And that's all 48-inch 900 and 42-inch 1500. Those valves weigh about 120,000 pounds apiece.
Those are running south, right?
They are.
In Mexico?
Yeah. From Agua Dulce,
right.
Which is just west of Corpus Christi, and all the way down to Mexico. And then you guys take it over, the Sur de Texas, y'all take it over, TransCanada takes it over as it 12 miles offshore.
Yeah. Used a lot in gas, some in liquids. Lubricated plug valves are also used in liquids. I used to work for a company called Nordstrom. Some of you may have heard of them in the lubricated plug valve market. So I'll run through this fairly quickly. We'll kind of cover some of the highlights of this and see what goes with that. Let's talk about history of valves. Get back to my presentation about 101. Okay, the earliest valves depicted were used by the ancient Egyptians. Did you know that? Just because today we have our modern technologies and cell phones and computers doesn't mean we're always the smartest people in the world. Valves have been around a long time. Roman used valves to control the flow of water and sewage. The first one was a gate valve. They used to put these in the fields coming off the river. They'd dig a trench over there and put what they call a sluice gate valve, so they could open and close this valve to water their fields. This has been depicted back almost 4,000 years ago. So when people think that valves today is new, no, we just got better materials of construction. This was made out of wood. And then it had a series of holes drilled right here, and it had a pin in it so they could open it to a certain thing, stick a pin in it, so it would actually restrict the flow. That's one of the oldest valve designs that we're aware of. This one you may not be so much of. This is a plug valve. This was dug up from the streets in Rome back in the 1980s. This valve dates to about 200 BC. Okay? This is a lead body and a brass plug that went inside the valve. They controlled water flow. It's a straight plug was in there, and this was used. Now you can imagine that's a lead body.
Lead body.
Yeah, it was for us today. That would be like, no, I don't want anything run through lead. But of course, at that time, of course, for a sewage valve, it's fine. We don't really care. So when we talk about valve technology, we just have better materials of construction. Valves have been around for just about as long as mankind's been around. Talk about lubricated plug valve. The modern design started in 14. It was originally designed for the mining industry that they came up with. There's many different types, non-lubricated, non-tapered, full bore. We talk about a lot of that. Again, the basic lubricated plug valve design, this was patented in 1914. Your valve, you have a plug inside here that turns. You see these grooves in the plug, the groove in the plug. This does not have a resilient seat in it. does not have any type of soft seated material in it. The valve uses what's called a sealant that's injected into the valve through a fitting shown up here, and the fitting, the sealant actually works as your seat. It's the only valve design out there that you can replace the seat in the valve while it's inline under pressure. It's one of the pluses about a plug valve. You can put a new seat in the valve while it's there. Anybody see anything different about the flange on this compared to a flange on this? Well, this is a low pressure valve. But did you notice that most valves today have what we call a raised face? You've heard of raised face valves? This is a flat face valve. What does that tell you? You don't see that as much nowadays. This is a cast iron valve. Remember I showed you the ANSI ratings before, where you had the class 150, the class 300, the class 600. There's a different classification for cast valves. This is a class 125. And remember what we talked about on certain 6A valves. If you have a 10,000 PSI 6A valve that is rated up to 10,000 PSI, this is a class 125 valve, and it's rated up to 125 PSI. Okay? They're called flat face valves, and most of the time when people install these, especially for higher pressures, because they made a class 125, a class 250, a class 400, a class 800, and what they would do is when they put the bolts of the flanges up, they put a gasket in there. And that's how they created the seal. Because you don't have this raised face portion to seal off with. Okay? Just a little sideline there. Again, this is a lot of nomenclature. This is out of a catalog, but it talks about tapered plug. You have a tapered plug that goes inside a tapered body. The more pressure you push down on that, the tighter the seal becomes. Okay? Rotating the plug creates a shearing action, which cuts off your flow completely. Overlap between the plug and the plug seat, so you got seat protection, positive shut off. Okay. A lot of this is sales talk. I'm going to move through this fairly quickly. If you want a copy of this or need to find out this information more in detail, if you're dealing in plug valves, let me know. We'll deal with that. Basic construction: tapered plug, tapered body. The deeper this plug pushes into the body, the tighter it fits, the tighter your seal. That's how that particular ball valve works. In the 1950s, because of higher pressures throughout the oil and gas industry, what happened was they decided to take the plug away from the stem, invert the plug, turn it over. You know, your taper now runs this way. What they did there, it handled the higher pressures, and it allowed this plug to turn more freely inside the design of the valve. So today, that's your pretty standard design, a pressure balanced design. It reduces the torque and works better for applications today. Okay. A pressure balanced plug is installed with high pressure drop. You might say, where are these commonly used? Two applications that you see plug valves being used on today, especially, and you'll use the second one you'll use in your liquid lines. First one is called blowdown. Now you don't blow down liquid pipelines. That doesn't work, but in natural gas pipelines you can do that. And what happens is you have to close off a section of line, and you need to work on that section of line. You need to get rid of the material out of the line. Natural gas can be vented to atmosphere, so we don't particularly care about that. Of course, your liquid, you cannot do that. So you don't find blowdown valves in liquid pipelines, but you do find bypass valves. And that's where you'll see a lot of your plug valves, because they handle the high pressure drop. Remember, I don't have a seat in this valve. We used a sealant.
What we were talking about earlier, the resilient seated nature. This is metal to metal.
Yeah, it's
You open up
metal
metal to metal, and you're creating that area, and this valve will take it. That's what it's designed for.
Yeah.
So you can have the high velocities and high pressure differential blast through there, and you can then reduce your equalize basically.
Yeah.
Right.
And then remember, how many of you know what a throttling valve is? You ever heard of the term throttling? That's where you put a valve in a partially open position and leave it, because you're trying to either restrict the volume or pressure through that valve. This is a great valve for throttling, because again, I don't have that downstream seat, as I showed you earlier, that's exposed to the flow. So you don't have that.
This goes back to David's earlier comment. The end of the thing is, what's the right valve for the right application?
Right.
You know, you can throttle with that valve. We prefer you not, Because what we don't want you to do is put the valve in the wrong application and then have a problem. You're gonna call us at, 12 o'clock at night when the valve wasn't sealed.
Yeah.
Right valve, right application. This valve is for throttling. It is to take that high differential, not cut that seal.
Because remember on your bypass, say I for example, have a 24-inch pipeline, a liquid line, and I've got a valve, a gate valve, let's say, in there, and I've shut the pressure off. Well, I've got 1,000, maybe not 1,000, 600 PSI against the gate. I've got atmospheric pressure downstream. I need to be able to do something with this pressure, so when I open that valve, I'm not going to have this rush of material going through the valve. You put your 2-inch bypass leg or 4-inch bypass leg around the valve, okay? Put a plug valve in there, you open that 2-inch line or slightly open it and continue to open it more. What happens is it charges the downstream line. When your pressure differential gets close, then you can open the main valve.
Then it becomes a balanced situation.
Yeah.
Right?
Then your pipeline balances, and you don't have this, and again, we don't worry so much about this in gas, but in liquids, one of the biggest things you got to be concerned with is when you send that first slug of liquid material down that pipeline, you've got a lot of inertia there. You got to deal with that inertia, because now you're putting stress and strain on fittings and flanges and bolts and everything else down there. You want to fill up that pipeline in the right kind of manner so you don't stress the rest of your pipeline downstream.
Hey, y'all are familiar with surge,
Yeah.
right? Everybody familiar with surge, water hammer, whatever you want to call it. You got that energy that you have to manage. Gas, liquids, you have a problem.
Yeah.
A previous company, I've been on site where a 24-inch line danced because they didn't manage it. It literally came off its footings and laid down. I've seen seam, that seam in that weld pipe split open. I mean, it just, it's hydraulics. Try to manage that pressure. That's what we're trying to do.
Okay, and again, we talked about the way we balance the plug, top and bottom, so that make sure we keep the torque down the valve. Liquid, what do they do? Their maintenance, they can be serviced in line. You can inject a sealant into the valve, usually a high pressure grease gun or a NAT gun. That's how you put sealant inside the valve to do that. It works. Again, I'll tell you to move through this. This is how we actually custom fit the plug into the valve. We use a lapping compound and lap the plug into there so it fits very well in the bore after spin the machine. Shows the lapping machine that's used for that. Okay, valve sealants. I'll run through this fairly quickly. You use different sealants for different applications. They're a lot used in oil and gas. I sold plug valves. We actually had a sealant when I was at Nordstrom. It was a food grade sealant. You could eat it. But it was designed for applications where they used either pure water or other things like that for that particular application. So again, right valve, right application. For plug valves, lubricated plug valves with right sealant to fit the application. That's the key for that. Many of those are made. Sealant fittings. Sealant fittings are designed to maintain the pressure, and the check valve's installed in the port. I'm going to move on. You may not have seen this before, but this is a blowdown on a gas line. This is a pig launcher. All of you probably know what a pig launcher is. Okay, this is a pig launcher. What they're doing is they've closed off the pig launcher. There's another valve up here. They've closed off the pig launcher, and they got to drain. Now they've got to blow off the pig launcher so you can open the door and put the pig in it. So what they're doing there is they're venting it. Quite frankly, if you've ever been around a gas pipeline when they do the blowdown, it's worse than a jet engine taking off and you're standing 50 feet from it. It blows and blows and it's noisy. Okay, but again, with natural gas, the plus side is you can relieve that pressure to atmosphere. Of course, today in petroleum, liquid petroleum product, we do not talk about anything touching the ground. No, we don't go there. We don't want EPA calling us and saying what's going on. But that's something that a plug valve is used for. That valve's only about 20% open. And you can imagine that pipeline pressure on this particular pipeline was about 1,000 PSI. So you can imagine you're blowing, and this is I think this was a 30-inch line. That's a 30-inch receiver there to put the pig in. A lot of gas in a small area pumped up and pressurized at that particular point. There shows a plug valve and a blowdown application. Here's your pipeline, pipe nipple. It's actually mounted in a vertical position. And that's how a lubricated plug valve. It's a manual operated valve, So if they have a certain section of pipeline, they isolate between two, usually ball valves, and they'll blow down that section of pipe for whatever reason that they need to do. Be similar for liquids, it's just you have to do something for liquids. No different there. Large plug valve, these are 24-inch plug valves, so they are made in larger sizes. We're sold to a company up in the Northeast. Again, prior to the late 70s, early 80s, pipelines, the plug valve was the preferred valve to use in pipelines, that and gate valves. Ball valves really didn't come into the marketplace until the late 70s, early 80s. Ball valves were only invented in the 1950s. So ball valves are still a fairly recent design when you compare it to the plug valve, to the old gate valve I'll show you in the front. So it's still a fairly recent design. Okay. Here shows an automated plug valve. This is an operator mounted. This is a plug valve mounted in this header. Goes up, it's interesting, there's a manual ball valve at the top of it. This is down in Florida, so they had this is at a compressor station, which is similar to a pumping station, which you guys will be familiar with. Coming through here, and this was a gas over oil high pressure operator that actually would open and close that plug valve. That's a Florida gas, by the way, for you guys in the back. Okay. Also on a pipeline, you may have seen something like this. This is a buried pipeline, again, natural gas. Here's a plug valve, and here's another plug valve. This is your control cabinet and your actuator for your valve. It's mounted above ground. The valve's down about 8 feet under this level in the ground. They really made a nice thing here, because what happens is if they have a problem with this valve and they can't shut down the pipeline, this is Williams, by the way.
Yeah, I can tell that.
What happens is that they can open these two plug valves, and this is a bypass. It bypasses the valve. And they can take the top off and open just one side and use it for a blowdown. So it really kind of does 3 or 4 times. I wish everybody did that with ball valves, to put a bypass leg on like that. Because it makes our world, especially because I manage a service department, when the guys go out and work on valves, it makes life so much easier. It really does, to be able to do that. Okay, so again, a very, very pipe application you see there. Now, we talked about bypass. Okay? This is a 42-inch ball valve on a pipeline over in Arkansas. What happened was they would close this valve. You can see the actuator on top of the valve. And then what they would do is they would, downstream, they would have to do work, evacuate, do whatever. Now, this is the pipeline where I've got 1,000 PSI sitting on this side of that ball valve. This, again, is a 42-inch ball valve. So, what happens when they finish the work and they want to charge the line downstream? They're like, we don't want to start to open this 42-inch ball valve and now have that 1,000 PSI of gas streaming down through there, because you don't open this thing in 2 seconds. It takes a little time to operate that big a ball valve. So what they built was this bypass leg right here. And on this bypass leg, this is a ball valve, this is a ball valve for isolation of the bypass leg, and there's a plug valve. So they open the 2 ball valves, and then they crack open the plug valve, 30, 40, 50% open, and allow the pressure from this side to charge the downstream side. And they set up in their control center, once the differential pressure between both sides of that valve reaches 100 PSI or less, the big boy opens. Gas flows, everybody's happy. And we don't damage this particular valve. So again, bypass, that's what this is. Everybody understand the concept behind that? Pretty simple. That's pretty common in the gas business. I'm not sure about the oil.
We'll do thermal relief.
Thermal relief, okay. Same type thing, yeah. So, but again, it's more than one way to, I guess, the old proverbial skin a cat. You know, to make sure you don't damage your main, you don't want to damage your mainline valves. When you start shutting down main lines, pulling out valves, having problems, you know, that costs everybody. This bypass leg, since it has 2 ball valves on the inside to isolate, if I have a problem with the bypass leg, fix it and move on, life is good. Okay. Pig launcher. Everybody understand what a pig launcher is, right? Depressurize your launcher, open your door here, stick your pig in, close it back up, move it like that. The reason I showed this was in the gas business, this is a plug valve. On the back end of the pig launcher, we call it a kicker valve. And a kicker valve is it's actually, when you get the pig in there and close it, you open this valve and it kicks the pig down the pipeline. So it's normally referred to as pigging, because you want to start establishing the pressure behind your pig, push your pig down the pipeline. That's called a kicker valve. Okay? All right, again, sales stuff, we're not gonna talk too much about that. Today, plug valves for a long time were used as mainline valves. Okay, today in the gas business, they're mainly used blow down bypass. That's all the prevents used. It's a throttling valve. It's the most robust design out there to throttle product. And many of them are still in service for lines below 8 inch. You know why we have to do that? Because of interstate pipelines, anything below 8 inch does not have to be pigged. And a plug valve is a reduced port valve. That means that the port going through the valve is smaller than the pipeline. Can you pig a plug valve? Once. Then you go open a pipeline and try to drag the pig back out of the valve, right? That's the only way you can do that. Many years of service, again, these have been installed for the gas industry. They were standards all the way up to the 1970s. Even in low pressure gas, that old cast iron valve I showed you to start with, prior to the polyethylene valve that came out in the 80s, that was the standard valve used in the gas business, especially low pressure gas in cities. Today, of course, polyethylene takes place in almost all of that. Maintenance is a key for plug valves. Move with that. Questions?
Up there, kind of started my own deal with 5 other partners. We started a valve that would compete with Orbit and did fairly well over about 5 years. Life changes. Y'all will learn that eventually as you get older and things happen. And I needed to get off of the road because I was spending a lot of time on the road getting this new startup up and running. And we grew it about in 5 years, we grew it from 0 to about 9 million. Brand new valve, new patent, new concept. So it was a fun, that's what I like doing, growing new stuff. Needed to stop, needed to just be in Houston to raise my 2 boys. So I started with a company called M&J Valve. I don't know if y'all have heard of them before. They build some small bore gate valves. You know, no, they are one of the, you know, they're a premier gate valve. There's 3 premier gate valve manufacturers in the world, and you need to know who they are. Cameron owns, Schlumberger owns Cameron, who owns the WKM World. SPX Flow owns M&J right here up off of 290, and Valve Italia is distributed through Quarter Ton Resources, and we build valves of that ilk: a fabricated gate valve, which is a slab, an expanding gate valve, which is a cast body, and then a hybrid of the 2, which is a CEX, or compact expanding gate valve. And I'll go over, what I'm going to do is go over how those valves work. This is not, we're Valve Italia by the valves. This is the mechanics of how these things work and why we think, not why we know, but why we think you choose these valves in these particular applications and where they're used, okay? So I focus on gate valves in general, obviously liquid world. What David said was true as earlier. One of my big customers I'm focusing on is a company called Williams. Williams gas pipelines are full of gate valves, full. You know, since the 70s, ball valves have come in because they were more competitive, they were more costly, fill in the blank, right? But I am working with Williams right now. We're going to stock stuff, but we also do special stuff. I'm working with Williams right now on a 12-inch 2500 class cavern storage valve. That main line off the thing in South Louisiana. Valve they're having issues with. We've designed a product for them. It's going to be metal to metal. That's what we do. So I can cover gas processing. That's my real world back in Orbit. But the last 5 years I was with SPX Flow as their global valve product manager in design and development and production and cost and all that kind of fun stuff. And now I'm here. So I'm going to use a presentation that I use as a large generic presentation. So I'm going to thumb through a lot of stuff. Who don't know nothing about us or the introductory. Okay, so gate valves. Again, there are this is not the only types of designs of gate valves. This is the types of designs of gate valves that we focus on here, okay? But there are, the secret to the valve world is, as soon as somebody comes up with a good idea, somebody else is going to try to come up with a better idea and differentiate themselves just a little bit, right? But it's about the right valve to the right application. You know, these valves wouldn't work very well in mining or slurry service. You go to a wedge gate for those. These valves wouldn't work very well in, you know, X service, because these are designed fit, form, and function to API 6D liquid type services or gas type services, right? You don't want to throttle them on and fun stuff. So, most basic form is the slab gate valve. And you remember the picture that David showed of the original Roman. You know, that is a slab of sorts, okay? It is a slab of material. That was in the case of wood. We use steel. It's basically plate material that rises and lowers in between your seating or your blocking agents, okay? Again, that's a good idea. A better idea is an expanding gate valve. Why expanding gate valve? What are the advantages of the expanding gate valve? What does that really matter? Well, slab gate valve seals with pressure. You're relying on pressure for the most part. Expanding gate valve, you're employing a mechanical wedge. It is a mechanically sealing valve. It is going to seal irrespective of your differentials, irrespective of your pressures. And I'll go into those details in a minute. And then the compact expanding, like I said, is a hybrid of both. Okay. I am technically challenged. So, okay. So, API 60 slab gate valve, like I said. The slab is basically a dumb piece of steel. Okay? Again, this slab concept comes in a design with an orifice in the plate and allows the valve to be full port and piggable. Okay, we've thrown that term around a little bit, and I interrupted David a minute ago. Let's just go to concepts real quick in terminology. So full port means if it's a 12-inch pipe, you have a 12-inch valve, and it's not a reduced port valve, then it's 12 inches all the way through. Pretty simple, right? Piggable, API uses the term through conduit. Does anybody know what that term means? Through conduit, heard it before. Okay, you can have a full port valve that is not through conduit. Okay, we don't recommend you pigging through a valve that is not through conduit. Through conduit, as API 60 defines it, is there is the same dimension and surface all the way through the transition, being the valve, you know, from end to end. This valve, from end to end, is the same dimension all the way through, and it's the same solid wall all the way through. So does the pig feel any cavity or void when it's traveling through that valve? Okay, where does that come into play? We'll get to this eventually, but think about a wedge gate valve. You've got a wedge gate valve, you've got your body, the slight taper, seats, you've got your wedge that is designed to fit in between those. It's basically your tapered plug, except it's on a rising and lowering, you know, and sometimes they're sharp if you need them to cut. Again, you know, valve for its application. Well, this wedge gate valve, when you pull this wedge of this gate up above this top seat, and you've got your valve body here, you've got this expanse in between these seats. As if you were pigging through this valve, that pig would experience that void. Okay? So that could be a full port valve. It could be 12 inches all the way through, but it's not through conduit, because when that gate pulls up, you've got a void. So full port is full port. Through conduit can be full port. Through conduit does not necessarily mean you can have full port and have a cavity in there. So if that spans is far enough and that pig doesn't have enough inertia and it drops, you got a stuck pig. Okay, so piggable and through conduit mean the same things. Piggable and full port don't always mean the same things. Right? Everybody got that? Very, very, very simple, but I have been, again, it's one of those things where you've learned, because I get a call from, this was many years ago when I worked for Orbit, and I get a call from, at the time it was Amoco Gas, now part of BP, down in south of Houston. And there was an engineer that was not too happy, and she explained to me that I needed to be there first thing in the morning. And I said, what does that mean? What's your first thing in the morning? She said, be here at 7. And I lived on the north side, so that required some trucking down. So I pull up, and they had, I mean, she didn't really explain it. She was a little livid, and I wasn't going to ask a lot of questions. I thought maybe she'd calm down before I got there the next day. Unfortunately, that wasn't the case. But she gets up, and I get out of the truck, and she meets me coming, and she's like, we got, you know, we ordered these valves, da, 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 and we got there's a pig stuck in this valve. And it was an Orbit, right? Again, this, for a 12-inch valve in a gate valve, this spans could be 2, 3, 4 inches, right? It could be big. In an Orbit valve, the Orbit valve is a unique valve, and it's a ball, if you will, but it's on a pivot. So when you operate the valve, it cams off of your sealing surface, not even, you know, a quarter of an inch. And that's big. But it'll cam off and it'll rotate. So when the valve is in the open position, you've got the, let's call this the ball. With the trunnion. You've got the seat here. I was not an art major, so don't count me. So you have a small gap here and here, and then a little bit larger gap here and here, because it doesn't matter. It's a single-seated valve. It's for processing. Right valve, right application. We don't want to sell you a valve for the wrong application, because then we get this call. I want your ass down here first thing in the morning. Get out of the car, I got a pig stuck in the valve. I was like, oh man. I started immediately going through my mind. When did the order come in? Did I say it had to be drifted? This, that, and the other, da, da, da. And then I go, okay, what kind of pig did you use? What does that matter? It's like, well, we don't recommend you using pigs and Orbit valves. You didn't order it from me. I just want to know what kind of pig did you use? She goes, well, we use ball pigs. That's exactly right. Okay. So I explained to her, I draw the same picture, a little bit better. I lost my artwork over the time. So the ball comes in, and you get the kicker, you know, put the pressure, ball shoots down the line, and ball is a spherical object about this diameter, moves into here, and what does your pressure do? Around the outside of the core. Ball comes through here, where's the pressure going to go? Nowhere. It's always behind the ball, pushing through it, right? And once I explained this to her, you saw her go, oh, hang on a second. I said, she goes, well, that explains a lot. I said, well, I'm sorry, you know, if you'd used a poly pig or a cup pig, but I never recommend you use, you know, right valve, right application. This is not a through conduit valve. It's a full open, but it's not a through conduit valve. Well, I didn't know that. Okay. I said, so then she goes, well, we've got this ball stuck and we got another one stuck about 10 miles down the pipeline. I was like, oh, so they loaded up another one thinking they were going to hammer it out, right? So, right valve, right application. know about your valve designs. This was, I mentioned, the first part of this was kind of rudimentary, but you know, that plug valve for throttling and blowdown service is what it's built for. It's what it's built for. So full port through conduit. Through conduit is pickable, always. Full port doesn't necessarily mean that. Okay, so slab and expanding gate. Again, it's not a negative term, just a description of how the valve, what the sealing member is. It's a dumb slab of steel. In the open position, this is at the seats. In the closed position, it's slid down in between the seats here, and that blocks your flow just like that Roman aqueduct. Expanding gate is a deviation of this in the sense that we've taken two pieces of steel and we use a mechanical advantage to wedge those, and I'll show you how those work. Both of these are full port and through conduit valves, okay? That in the open position, seats are lined up here, and that ID of that hole is lined up with your seats, so your pig never sees any void, right? Smooth transition all the way through. Same thing with this. On our CEX, not so much, and I'll tell you how that works in just a second. There you go. See?
You move the mouse off of it.
How about that? Okay, so exploded views. Again, slab gate valve with your sealing systems of your seats. This is a fabricated body. Okay, there are some manufacturers. Dave was talking earlier about forgings versus castings. We will build this in a fabricated body or a cast body. We have chosen to stock this in a fabricated body. Our expanding gate has a cast body. That's the industry standard. That's just what everybody does. Very similar in design in the sense that it's a rising stem. Okay, your ball valve, you're dealing with torque, quarter turn, fairly easy. You were talking about the massive requirements for actuators earlier to turn ball valves, especially metal seated like the Mogus, you know, high temperature steam and all that kind of fun stuff, and those big actuators. I quoted some the other day, the electric operators on these things, a whopping 6 horsepower. It was crazy. Difference in ball valves and gate valves. So gate valves, it's thrust, okay? We're just pulling that gate up and pushing it down. You have a multi-turn. You have a multi-turn through a threaded drive nut that you just spin it, and it pulls that gate up and pushes that gate down. Very simplistic, right? Doesn't require as much. It's not as, I mean, they're still big. The bigger the valve, the higher the pressure, the more horsepower, but not as difficult to do these. So generally in gate valve world, so let's talk about gas pipeline and actuation versus the gate valve world. Generally a gate valve is going to be located, for the most part, except pipelines, but in the stations and stuff, you've got plenty of electricity. So you're going to be using electrical operators, you know, limit torque, road torque, EIM, fill in the blank, right? Out on the pipeline in the middle of nowhere, we get into the high pressure gas, you know, where you need to operate this in the middle of a cornfield. It's a little bit different than the liquid world. Liquid world, generally in your stations, you've got electrical available to operate the gate valves, okay? So I'm a gate valve guy. So exploded views, like I said, you can see the differentials of the gate and the segment, and I'll show those in just a second individual page. Okay, slab gate valve. It is a full port through conduit in the closed position. This currently is in closed position. You've got the gate that you've slid down in between. If you noticed, the bottom of the valve is a lot longer. Let me go back up. You've got a lot of bottom of the valve here. This, when the valve closes driving down, this is located in the bottom of the area. You need this bottom down here. There are some valves inside the fence in your facilities. They'll be a lot shorter. This won't be there. They'll use what they call a coupon gate. They aren't as worried about the valve being open and having that gap at the bottom being exposed, because you don't pig in that area inside the fences generally. So they'll use a less costly valve, less costly design. So when it pulls up, this is gone, and you'll see that in our CEX in just a minute. So, how does a slab gate valve seal? In the closed position, similar to a ball valve, you've closed your gate, and you have a series of springs around the outside of the diameter of the seat, behind the seat. That helps energize and keep it a constant pressure on the surface of the gate, even in the full or open position, full open or full closed position. But when it goes into the fully closed position, you've got the pressure in your pipeline against that gate, against the downstream seat, and a crevice, an area behind this seat, that pressure energizes there and energizes that seat against the upstream side. Okay, so it's a pressure sealing valve. This is a bidirectional valve. Doesn't matter which direction you put it in. It's going to operate the same way. Gate, similar to a floating ball valve, okay? In that the gate is not statically pinned at the bottom or at the top to the stem. It literally has what we call a T-handle and a slot right here at the top of this. So that just slides in there, and it allows that gate to move depending on your pressure and your direction. It will float one direction or the other, completely bidirectional. Earlier I interrupted David briefly, and I talked about you've got directional valves, like a check valve, and you have bidirectional valves. But there sometimes people use the term with the preferred pressure end, okay? Let's jump back to what I was talking about up here with this orbit, okay? The orbit is a bidirectional valve that will hold both directions. You shut the valve and it will seal, period. Same thing with the slab gate valve, the same thing with the expanding gate valve. They will seal in either direction, period, both bidirectional. I'll get to the expanding gate, the orbit, they have preferred pressure directions. And that comes to play when you're actuating, but that's the only time it really comes into play. But what we're talking about are bidirectional valves. This is a double block and bleed. We touched on double block and bleed earlier, but David, I think, kind of he just kind of passed it over. Everybody familiar with the term double block and bleed? Okay. There are more stringent requirements, double block and bleed, a DIB and a DIB2. Are y'all familiar with those and their differentials? Yes, yes, yes? Okay. So these are all double block and bleeds. We can double block and bleed with this valve, and we can DIB2 with the expanding gate, okay? So again, where you choose to use this valve is more about what your company, ultimately your culture or your policies are in terms of what you want to achieve at that given installation. Is there, I mean, what do y'all normally, y'all are more, you mentioned more of an expanding gate use?
I believe so, yeah.
Okay. Okay, so the slab gates, historically, like I mentioned the planes for Exxon, that's going to be a slab gate mainline crude line. It's going to be a 36-inch 600. Generally, I've seen, from my experience, crude lines are, for the most part, slab gates.
Like I said, we don't have any on my project. That's,
Right.
That's a mainline valve, so I can tell you.
Like the Keystone.
Yeah.
There were half a dozen that were going to be slab gates.
Yeah.
Okay? When you get into refined products, just in my experience, what I've been exposed to, refined products or critical water crossings, things like that, you'll get into expanding gates, but you get into your gasoline, eanes and anes, where you're shipping them from one point to the other, that's where generally people transition to a double expanding gate valve. So the seating this is the slab seating. Do we want to go into the detail on slab seating? You want to focus on the expanding? Okay, so slab, different people use different things in their designs. The primary competition uses a series of nylon and Vitons that's encapsulated inside the seat base, okay? We use a very similar design of a nylon and a Viton material, just a little bit different form, same function, same spring system behind, but what happens, like I said, is this is one of the seats on the valve. When the valve comes in the closed position, the gate is in contact with the resilient material. Pressure, if it's in this direction, it pushes against the gate, against this exact seat downstream, and then pressure will be behind this and a piston effect against that seat, against the gate, affecting your upstream seal, okay? So the beauty about the gate valve is when you shut this gate, you have trapped fluid or media in the body, and you can bleed that body, double block and bleed. So when this gate goes to the closed position, you have product here at lower pressure, media in the body, and you can go on the outside of it with a manual bleed valve at the highest point.
So we'll talk about, well, the differences, typical applications, traditional as typical non-traditional, which one is used most often and which one is used least often. A bolted body. This shows a picture of a bolted body design. Pretty simple to see. You see this is a flange by flange valve. Everybody understands the difference between flanged in and weld in. The body is three pieces. You have what's called your closure or your ends, and then you have the main center section where the ball and all the seats and everything goes into the valve. If you'll notice, you see the bolts on either side. This is my model here. You can see it. It is a bolted body design. That means that the valve is bolted together. It's also called a side entry, which means, in nomenclature, the valve means you can literally, when it's mounted, you can get in the side of the valve. So that's what it's meant by a bolted body valve. All right. Construction, you can see a basic construction here. Here's your end. These are your seals, O-rings, your seat, usually some type of another sealing element within the seat. Your bolts, center section, valve stem, your trunnion mounts, the ball, and just reverse here, doing that. Where's your laptop? So this is what you have with a bolted body design. Pretty simple how they put that together. All right, so a welded body design, this is an actual picture. You don't have any bolts. The three pieces are put together and they're welded together. Now you might say, why do you have a bolted body versus a welded body? They do the same thing. The internals are all the same. They're put together, and you may say, well, why would you make both sides of ball valves? Here shows a construction of an all welded body. Instead of having bolts, where they put the three sections together, all this is welded. But the internals are the same. Ball, trunnion mounts, valve stem, all that's the same with that. You might say, why do that? Here shows a bolted body. This for out at a compressor station. You can see the intercooler back here in the back of the compressor station. Comes in, it's mounted to flanges, hand wheel, the gear operator on top of the valve, pretty standard, right? We talked about, showed you this picture before, the buried welded body is in the ground. Now why, you would say, what would be traditional about that? Anybody want, why would you have a bolted body versus welded body? Do you know why?
We need a different process. We need a different process of what's going through it?
No, the valve doesn't care. You run the same materials through both valves. Biggest thing is a bolted body valve in a traditional sense is used in above ground applications. If you have a valve that's above grade, in most cases, not all, remember, I'm sure you said this during your presentation, I'm not going to stand here and tell you it's 100%, there's always exceptions, but for most rule of thumb, a bolted body valve is used above grade. You know why? People don't want to bury flanges. They don't want those buried in the ground. Okay?
It's repairable.
Right. Biggest thing too, we're going to talk about that is when all this is welded together, if the valve has an internal problem, I have to take it and cut it apart to work on it. If it's a bolted body, I can disassemble the valve and repair it. Okay? So, traditional installation for an all welded body, where you don't put any flanges, is below grade. Everything's welded up. Okay?
Do you ever have to do between a bolted and a welded, depending on what materials you're using between the casting, forged, or the pipeline?
No. All these are forged valves, different materials, doesn't matter. Because again, like I said, it only has to do with the way that the body is put together. Either bolted together or you weld it together. Everything else is the same. Okay?
So, everybody with gas pipeline applications, raise your hand, I guess.
Yeah. Yes.
You'll have new projects, expansions, that sort of thing, or and it's really important with, so all welded body, you cannot take them apart. It is what it is. We used to call them throwaway valves in the old days when we were building nothing but bolted body. But it's really critical when you all put those things out there that you take care of them, the integrity of the valve, particularly if you're putting it down underground, or that you protect it from getting anything inside of it, because you can't pull it apart. You can't repair, scratch balls and that sort of thing. So it's really important on your projects that you keep the cleanliness of it before you put it in, and you ensure that it goes in without getting a lot of stuff in it.
Right. Okay, so let's talk about non-traditional applications. This was an application on some repair work we did over in Georgia a few years back. This is a 12-inch pipeline that's going to a power plant. We had to repair this valve, but they could not shut off the gas flow because it was a combined cycle plant that used natural gas, of course, to produce electricity. So what we had to do, they had to come out and put a temporary bypass, another company did, so we could actually repair. This is a bolted body valve that's been buried. So it's not always the case that you don't bury bolted body valves. There are different reasons for that. We'll cover those in a minute. And then we talked about, here's bolted body valves. This is in our shop up in Oklahoma. And this has what we call a stem extension. Sometimes people call it a high head extension. Because this is a buried valve. If you'll notice, this is black up to this point. When this valve is installed, about this much of the valve is all that's going to be showing out of the ground. So we do this work, we extend all the lines up. This one has a gear operator on top, but this is a buried service valve. Now this is a bolted body too. So this is not 100% rule of thumb, but as a rule of thumb, most people like to bury all welded valves. They just don't like to put flanges and bolts in the ground. Possible corrosion, leak path, whatever else we do with that. Then you have this situation here.
Are those lines
This is,
like body bleed?
I'm sorry?
The extended lines, are those for like body bleeds?
Well, the extended lines are to blow the valve down, and we'll talk about that when we talk about block and bleed here in a minute. And also the lube lines. You have to inject lubricant or sealant into the valves. That's what the lines themselves are extended up for.
Yeah,
Did
lube
that answer
fittings
your
that go
question?
into each seat.
Okay. Here's an all welded body that's above ground. Now, part of the reason for this was availability. This is a 42-inch valve. I only stock a 42-inch valve in an all welded body. I don't make a bolted body. I will tell you, we'll make that bolted body if you want one. But this one was put up, if you notice, it's got a big flange where they bolted the valve into the line. So even though you prefer to bury welded valves and keep bolted valves above grade, it's not always the case. Sometimes it's availability, sometimes it's price, sometimes it's other factors that are involved in what you can do to build a pipeline. So that's why you can do it that way. Another way, this was an elbow that comes in, makes a 90-degree turn. I love the way they built that platform. The guy has to go out and work on that actuator. Makes all the difference in the world. He can climb right up there and do all the work he needs to do. But that's an above ground. That's at a compressor station over in Arkansas. That was a Fayetteville Express pipeline that was put on that. So welded versus bolted. A bolted body valve is field repairable. I can take this valve apart and fix it. Welded body, I can't do that. I can't cut it apart in the field. Okay? A welded body offers fewer leak paths because I've got O-rings and seals and everything in here. When people bury it in the ground, they don't want to take a chance on a leak. So that's why they decide to go with the all welded body. Bolted body, if this is, this is a flanged end valve, right? This is a flange. I can, on the bolted body, replace the flange and put a weld flange on here. So I can change the valve over and do different things with it. I can't do that on a valve that's man, this thing today. On a welded together body, I can't do that because I can't cut the valve apart and do that type of work to it. Okay? Welded body is usually more compact. Okay? Sometimes when they put this body together, it's a little more compact. Your takeout distance is the same. I don't know, did you talk about ANSI standards on takeouts? Okay. The bolted body is traditionally used above grade. We talked about that. And the welded body is traditionally used below grade. Okay? The internal construction is the same for both. On the trunnion mounted ball valve, this would be for most manufacturers. They would be identical. Operating torques are nearly identical. So when you size actuation or anything for the valves, most of the actuation companies, John, you can correct me on this, they never ask whether or not the valve was a bolted body, welded body. All you want to know is pressure class and the diameter of the valve, so you can size the actuator for it.
Yeah, well, yeah, that, we ask what valve it is. Typically, we'll ask what valve it is because that specifically will tell you the torques. Our torques.
So really it doesn't matter as far as actuation sizing for a trunnion mounted ball valve, whether it's bolted body, welded body, is kind of irrelevant with that. Both styles can be automated. You can add actuation and everything to them. Most valves meet ASME B1610 or API 6D. I don't know if any of you, this is American Society of Manufacturing Engineers, ASME. We're talking about there the B1610 on every valve from flange valve from, I guess, probably ½ inch up through 24 inch. This dimension between a valve on raised face valves, this end-to-end dimension, is identical for every manufacturer, from 2 inch, from about ½ inch up through 24 inch. So if you buy my valve, put it in your pipeline between flanges here, and then 10 years from now you have to buy a company XYZ valve, you can take mine out, put theirs right back in, everything fits. Again, another industry standard is what we call a takeout. The takeout dimension is this dimension here between the ends of the valve on a flange end. On a weld-in valve, it's not that way because you're welding pipe, you don't care. You'll cut the pipe to make the valve fit. But on a flanged-in valve, that is a standard, up to 24 inch. After 24 inch, the larger sizes, it's called API 6D. Those dimensions are also fixed. Again, flanged-in valves only. So if whoever's you buy, if you put a valve in there today and you have your piping fixed with flanges on both sides, pull one out, put another one in there, doesn't matter the manufacturer, they fit. Another industry standard that we have. Okay? Questions on that? That's ASME B1610. By the way, you guys not taking notes? We're having a test after this. Did you not know that? Oh, okay. Right. End users have a preference. I mean, it depends on where they put them. We've had some customers, and we have some customers right now. They will not bury a bolted body valve. I just tell you, I'm not going to do it. If you don't have one, I'll go buy one from somebody else. Okay? Some people, they don't care. There are many, many thousands of bolted body valves that are buried in the field today. They work fine. Some people just have a preference. Again, I talked earlier, availability. I need a 30-inch 600 valve, and I need it in 2 weeks.
Yeah.
Guess what? I have a bolted body. Okay, well, that's all I can find. Send it to me. That happens. We get a lot of that. Okay. Most people use a variation. Some people, just availability, pricing, stock, project. It just depends on a lot of variable factors. And both styles have been used in every type of application you've got out there. Okay. Most manufacturers make both styles, welded body, bolted body. Many of them choose a style depending on application availability, pricing. Major difference is the bolted body is field repairable. It can be repaired. And similar in internals and everything, okay? Any questions on that? Everybody pretty cool on that?
Which one's more expensive?
Depending on the manufacturer, for us, there's very little price difference between the two. Some manufacturers, a bolted body sometimes a little less expensive because you have less parts. Remember, you got bolts and studs and nuts and all that to put together. On a welded body, you just stick metal together and weld it up. So it depends on the manufacturer. For us,
You got to pay a welder though.
Yeah.
yeah, you got to pay a welder. So for us,
It's
quite
almost
frankly, there's really not much difference at all in price. So some manufacturers,
Right.
yeah, some manufacturers make a difference in price, but we try to real quick, and then we're going to get into double block. Okay. What we're talking about is a double piston effect seat.
Are y'all familiar with I talked about the self-relieving where internally the slide gate valve, if you overpressure the body in the closed position, it will burp or self-relieve to one side or the other. That's self-relieving. There's one particular company that's their standard.
Okay. What happens is, and this is a design philosophy that many manufacturers have had. First and foremost, we offer both designs, a self-relieving seat or a double piston effect seat. Okay? What happens is when you have pipeline pressure that goes into the valve, when you open the valve, not only does the pressure flow through the valve, but it flows through the body of the valve. Okay? There's got to be room in there for the ball to turn, so there's the body that exists, internals of the valve, between the ball and between the walls of the valve. That's called the cavity in there where the ball's got room to work. But when you close the valve, this seat in the downstream area closes off. This body pressure is still trapped in the valve. Remember, you had gas flowing through there, so remember when you open and close that valve, and think of it this way, as you open and close the valve, see, this body cavity is exposed right here as I open and close the valve, so it fills up with pressure. Now I close off the valve, and see now I've closed off the flow stream, but guess what? What's inside the ball and what's in this cavity is trapped pressure. So I always have to be aware it's there. That's why if you ever ship a valve back to a manufacturer for repairs, ship in the open position, because quite frankly, if you ship it us in the closed position, we're going to turn the truck around and send it right back to you, because I have no idea what's in there, and I'm not going to take a chance on one of my employees opening that valve and something go blow out of it. So I always make sure. But on the double block, on the trailing mounted ball valve, there's another way to do that. We'll cover that here in a minute. But what happens is, it's called self-relieving. Think about the seat self-release. What happens is the seat design is the valve sitting there. There's no as your downstream pressure drops in the closed position, the valve recognizes the seat, realizes this pressure is going down there, and it automatically starts to relieve this pressure out of the cavity. And it will block off, and when that body cavity pressure, for the most part, relieved, all your pressure is held behind that seat on the upstream side. That's called self-relieving seat. Sometimes people will refer to that as a ball valve that'll burp. If anybody ever talks to you, says, do your seats burp? It's an old school talk.
Yeah.
But that's what happens is, because this doesn't usually relieve, just like that. It'll sit there and it'll relieve a little bit. It'll stop, and as the pipeline pressure drops, it'll relieve a little bit more. And then now, it never completely relieves the same pressure here. It'll maintain a little bit of pressure. But by and large, most of your pressure will relieve. It's called a self-relieving seat. It's a good thing that you don't have to maintain the pressure in its cavity. All your pressure is still maintained in the pipeline. That's a good thing. The bad thing is, suppose this valve, now that you've closed off and the seat's relieved, suppose this upstream seat leaks and it doesn't seal off. What happens now? That means that your material, this upstream seat has a minor leak. Pressure builds up, it leaks into this cavity again, and what happens to your downstream seat? It wants to relieve that pressure. So I have a leaking valve. There's not much you can do to fix that by design. Okay? So now you have a problem. That's called a self-relieving seat. Back to the other picture. Now, a double piston effect seat works in a little different manner. Kevin, you got Again, as the pressure builds, you open and close the valve, your body pressure builds up in the cavity on a double piston effect. The reason they call it that is because we're doubly sealing the valve. When you close the valve, I don't have a self-relieving seat, this pressure does not leave the body cavity. It stays there. You might say, well, why would you need that? Number one, remember the scenario I gave you, if the valve's closed and you have a leaking seat here at the upstream side, well now, this seat doesn't relieve, it holds the pressure, so now I in effect have a double sealing capacity on that valve. Secondly, I don't know if any of you have ever been involved in an application on a valve in front of a pig launcher. There is a rule under API that talks about you need to have a double seal in front of pig launchers, because when you open the door to the pig launcher, or whoever does that to put that pig in there, the only thing maintaining that pressure in that downstream pipeline is that valve that's in front of it. So this would make a lot better sense. Now I have double seats to make sure that that valve doesn't leak back into the pig launcher or receiver, the one, of course, where you take the pig out, that you have the issue with that. Double piston effect seats for a lot of manufacturers is an upcharge. They charge you extra because it makes a difference. This down here is drawing showing you how the pressure energizes the seats here. But in a nutshell, what I was explaining to you was there's a difference between what's called the DPE seats and the self-relieving seats. DPE seats are usually more expensive by most manufacturers. We standardize on this.
And that's mostly what you use in your gas system. Almost all your specification mandates
Right.
DPE.
Any question about,
But not in liquids.
any question about DPE seats versus self-relieving seats? Everybody understand that? Okay. And one more. We're almost at the end, folks, so bear with me, everybody stay away. A valve with two seating surfaces. Remember, I have a trunnion-mounted ball valve. I have seats on both sides of the ball, right? They're spring energized and hold the seats tight against the ball. And as the pressure builds in the pipeline, because of the way the seats are designed, the increased pressure pushes the seats even harder against the ball, giving you more sealing power. We provide the blockage of flow from both valve ends when the cavity between the seating surfaces is vented or drained. So what happens is my ball valve is in the closed position. Here we're closed. Everything's blocked off, right? But we know that I've got pressure in the hole in the ball, right? And I got pressure in this cavity, the room that allows the ball to turn. So the question is, how do I get that pressure out of that valve and not, drain one or both ends of the pipeline? How do I do that? Very simple. In the bottom of every trunnion-mounted ball valve, this one doesn't really have it. In the bottom is a plug. Just a great big threaded hole with a plug in it. When you buy the valve from us, we put a piece of pipe and a little elbow, and out here, about, a foot or so away from the bottom of the valve, we mount a small ball valve. So what happens is that when pressure in here is trapped, you can go down and you can open up this valve with the valve in the closed position, and you can drain all this pressure out of the cavity, out of the ball, out of the cavity around the ball. So guess what I've done? I got two seats, right? I have double blocked the flow with the seat on both sides. I blocked the flow from the downstream side. I blocked the flow from the upstream side because the valve's closed. And now I have bled off my pressure. So I've double blocked and bled the valve. Does that make sense? Double block and bleed. Another thing it tells me is when I open that valve at the bottom and the valve is in the closed position, you'll hear the gas blowing out, and eventually you'll hear it slow down. And if the valve is good, it'll stop. But if I open that and I keep having blowing coming out, what's wrong? I've got a seat leaking somewhere. But if I got pressure on both sides, we don't really know if it's upstream or downstream. But I'm losing pressure. So I can go out with this valve close the valve, if I can shut down the line, and open the bleed valve, and find out my seats are good, right? If you're going to do repair work downstream of this valve, wouldn't the maintenance guys really appreciate it if they found out the valve's going to hold pressure before they go out there and start working on the pipeline? Of course they would. And we even can perform something, if you have one of these in your yard that hasn't been used and you want us to check it, you know what we do? Close the valve, and at the bottom where your valve is here, we'll hook up an air line and pressurize it from that way. It's called an inside-out test. We'll pressurize the cavity while the valve's closed and put a gauge on it, and if it holds pressure, your seats are good. We just reverse what you normally do with the pipeline. Well, I said the pipeline under pressure. You can do that too with testing your own valves. So, everybody understand, double blocking bleed is not complicated. Double block and I bled pressure.
Can you explain the difference between DIB1 and DIB2? Hey, you were complaining about not enough questions, so here we go.
I'm just glad you asked it. That's all you, go ahead.
That's not.
Let me go get Rudy Garza.
That's
He
dual
wrote it.
directional.
Yeah, go get the guy that wrote that.
Dual directional seats.
I'm sorry?
Dual directional. It's dual directional seats and single directional seats.
Yeah, I mean, that is in a nutshell.
That's the nutshell I got. I always got to explain.
Yeah, it is. Div one, I mean,
It's where
Div
do you
one.
put them? It's where do you put them
Where do you put
in
the
your
pressure
particular
when you're doing it?
application.
Yeah.
If you want your upstream seat relieving or if you want your downstream seat relieving.
Go back a slide, go back a slide.
Yeah,
Yeah, I mean, like I said, this is, and I don't have many to split, but.
But DIB one is
Here.
DIB one is dual piston effect, which is what we provide in most of your applications in gas transmission. You don't want, like he was saying, if it burps downstream and you've got guys who are working downstream of that, like on a pig launcher, then you don't want it burping downstream. But in thermal bypass applications where you want it to relieve upstream, for example, you put a self-relieving seat upstream and a DPE seat downstream.
That's a Div two.
Yeah.
That-
Gotcha.
That achieves,
That's a, two, yeah.
that achieves it.
Yeah.
And what you're doing is you're changing the mechanisms of allowing the release, you know, in terms of putting loading pressure, like what was the terminology when you reverse, when you put pressure to the inside of the body?
Yeah, it's called inside out.
Inside out test, you
Yeah.
know, I mean, you load up pressure on one end, isolate the body, load up pressure on the other end, or pressure in here, relieving this, and it's simply a factor of how you test that to get to that end.
Right.
Okay, and you achieve it by DPE and a self-relieving seat.
So Div one, both sides. If you had double piston effect seats, as we talked about, you're a Div one valve because I've got pressure blocked on both ends. Div two would where I would, and we sell valves to customers. We do a lot of this in liquid. We sell a lot of ball valves in liquid applications, okay, besides gate valves.
Yes.
And the reason, the thing about that is a lot of times what he's talking about is when you want to, if you shut that valve, you know yourself, it's a liquid, it's not compressible. If this valve starts to get hot, that pressure's got to go somewhere, right? See, with gas, we're infinitely compressible with natural gas. We don't care. But I'll have a thermal bypass installed on this, which is we have a vent at the top of the valve,
To the back.
and we'll tube that back over to either your pipeline or the pipe nipple or to the flange, to the upstream side, because you want to relieve that excess pressure back into the pipeline, right? You don't want to relieve it downstream if you're working or doing whatever else that you relieve the pressure off of. So that would be a Div 2 setup.
So
And
that
we-
pressure that you're relieving onto the upstream side
Yes.
has to overcome the pressure inside the vessel.
It has to be a higher pressure than what's in the pipeline upstream, yes, before it will relieve into that, because it usually uses a relieving valve, a small one, that's in there, and you know, your pipeline pressure is plumbed into that. So if your upstream pressure is, say, 800 PSI, that body cavity is not going to vent back into that pipeline until it exceeds that 800 PSI.
So it has to be like 801.
So we'll put a small PSV, something like that
Yeah.
over here.
Yeah.
You can do, that's exactly right. It's usually a one-way valve too, that'll be in that system, because once that pressure's relieved, you don't want to cut it back.
It's a ball check.
Yeah, ball checks or something.
Check valve.
Check valve or something, right. So that's what, so, Div 1, Div 2, okay? Everybody understand that? DIV is the new standards that API 6D has specified. Quite frankly, it came out of Europe. Europe has had tighter specifications on valves than the U.S. has had. So what they're trying to do between the American markets and European markets, we're trying to come up with standards for worldwide valves with doing that. So that's why they did one and did two. Okay? Questions about that? Any?
Most of the pipeline, just as a side note, most of the pipeline valves in Europe are all metal.
Yep.
They don't use a lot of resiliency.
No, not at all.
It's
Just their philosophy.
I mean, it's just different, difference in philosophy.
Yeah, difference in philosophy. All right, so the body cavity can be vented or drained, and when I say in the open and closed position, that's for most manufacturers. There are some exceptions. And the valve can be tested for integrity and safeguard. Again, double block and bleed, we're back to, okay, how that works. So everybody now, if anybody asks you, is that a double block and bleed valve? You'll find out somebody knows what you're talking about, right? Now you understand. It's not complicated. Do you think it is? We double block and we bleed. There you go. Double block and bleed. Fire safe. Okay. These are standards that are out there in valves today. Under simulated fire conditions, I watched one of these. They put natural gas burners around a valve, and they fill it with water, and then they light the fire, and they cook the valve. And you see how long a valve can hold under fire conditions. Now, don't you think that would be pretty important around a compressor station or something like that, or a pump station? That if there was a fire at that pump station, how long is that valve going to hold pressure? Because you don't want it releasing and creating more issues. So the standard that's out here today is API 607. That's for plants and facilities. Okay, plants and facilities. So a compressor plant would fit under API 607. Make sense? That's a particular standard. Fourth edition is out there. There's been several revisions. This was a new one about, I guess, 7 or 8 years ago, the API 607 when it came out. Not every manufacturer fits that, has done that particular testing.
Is it only API or NFPA code around the
607?
Well, no, just with the fire protection on the valves.
I didn't understand the question, I'm sorry.
So with the fire safety on the valves, is there any NFPA codes, or is it all API?
Usually all API.
Yeah.
Everything's pretty much, except, I'm going to give you an exception here, okay?
6FA.
Yeah, 6FA is a standard in trunnion ball valves. It's also international. This is pipelines and gathering systems. A lot of times the ball valves will be stamped API 607/6FA. That means it meets both standards. Our valve does. API 607, API 6FA. So you understand the difference. 607 is plants and facilities. 6FA is gathering systems and pipelines.
I'm assuming plant facility is more stringent?
There's slight differences, variation. I think the burn time, I don't hold my feet to the fire, but I think the burn time on the 607 is a little bit longer than 6FA.
I've experienced a 607 burn test and what they do. I don't know, I've never experienced a 6FA, but the 607 is they heat it to that, they light the burners, burn it for X period of time, and then shut the burners off. There's a time period, and then they hit it with water.
Yeah.
And when they hit it with water, they're trying to find those coefficients of expansion and what the leakage rate is to meet that.
Right.
In 607 being inside a facility, you've got a refinery, and somebody's going to be putting water on it. So that may be the difference. I'm not sure. I've never seen a 6FA test.
I don't think I'm an expert on 607 and 6FA. I just know that we meet both standards, so we can do with that. The next one is EXES 314. This was actually came out March of 14. That's the reason they call it that one. And this is the second edition. It's 2A. This is Exxon's. Exxon has their own standard for ball valve. Exxon has their own standards for everything. Of course, trust me, they do. When you see we see bids for Exxon, we're like, oh God, what do they want now? Because it's always something different.
Regard?
Yeah. They have additional requirements, and this is what Kevin was talking about: rapid cooling, more stringent allowable leakage rates. Remember, metal expands when it gets hot. Well, when you hit it with rapid cooling, like you dump water on or something, you're going to have this quick shrinkage. So they want to make sure that that fire-safe seal that's in this valve can accommodate, again, the coefficient between the materials and the sealing material that's in there. Years ago, we used to use asbestos for that. Of course, we don't use asbestos anymore for anything, so we use other materials, but that was pretty good.
That's good stuff.
Yeah. BS 6755 is a British standard. This is for, used to be, this was a big one for BP. They always had BP, you always had the British standard they use with that. It's been reworded, so API 607 3rd edition today is pretty standard. And then ISO, and if you're dealing with you guys with TC Energy, especially on the Canadian side, we get a lot of ISO standards. Okay, and I'm sure you guys see that on some of your projects and all. It's a European spec, like the British standard specification, very much like API 607.
So everyone here is US, so there might be a few Canadian, we're trying to
Yeah, separate.
separate, and they're still going through some of that. You'll see some Canadian specs on some stuff, but for the most part, we're
Okay, so API's fine. Again,
This ISO spec, it basically adopted the 607 5th edition. You know, all of waterways, Coast Guard, anything near water, the Coast Guard can't spell or use API 607 properly in a sentence, but they know this ISO standard, and they know those numbers by heart.
Yep.
I mean, yes.
and so when if you're dealing with interstate pipelines and you're having to cross a waterway,
that's the number that the government, the U.S. government's going to come at you now with.
yeah, they're going to come at you now with the the ISO. The API is.
They basically absorbed it, but they don't know that. They're box checkers. You know, it's like, does it meet the standard? Well, it meets API 607 5th edition. Does it meet ISO? Yes.
Yes.
Yeah. And I was previously at a marine terminal, so everything was ISO.
There you go. There you go.
Who knows what NACE stands for? Anybody?
Association of Corrosion
Engineers.
Yep.
Thank you. Very good. National Association of Corrosion Engineers. So this was a standard, and in the MRO 175, it was pretty simple. Do you know where they came up with the MRO 175? The very first meeting of the engineers was in late 1974. And in January of 1975, they adopted their first standards, MR 0175. Of course, this has been exceeded now. There's some newer versions that are out there, but that was the very first one. And what we're looking for is H2S contamination, natural gas, hydrogen sulfide. Hydrogen sulfide, years ago, was bad news for valves because in the manufacturing process, they used a standard material, standard steel material, and what would happen was when it was exposed to hydrogen sulfide, the valves would start to develop certain surface cracks interior of the valve. So people found that out and said, well, what do we got to do to fix that? So in it was sulfide stress cracking, SSC. So in an accident in West Texas, believe it or not, the Texas Railroad Commission asked the industry to write a document to help prevent such incidents. Back in the early 70s, they actually had an explosion. And it was traced back to the idea of corrosion within the valve from the hydrogen sulfide. Hydrogen sulfide, for a lot of you, is also called sour gas. I'm sure most of you have heard of sour gas. That's what that is. It's an excessive amount of hydrogen sulfide. So they came together and wrote the first one 75, and then the manufacturer responsible meeting metallurgical requirements and user responsibility, material use, satisfactory intended requirement. I will say this to you, I know from us, and quite frankly, most every other manufacturer out there today is NACE standard. That means the valve will handle sour gas as well as sweet gas. Okay? So it's not a problem. But it'll be stamped on the nameplate of the valve that says NACE, N-A-C-E. If you look at a valve and it doesn't have that on there, don't put it in sour gas. It's not a NACE compliant valve. Okay? But that's how this all came about with NACE compliance. Okay. More pictures. There's another natural gas. That one's pretty cool. You got valves, operators. That to me, you know, somebody walking by that would think that looks like a mess, but quite frankly, there's pretty good reason for that. I like to take pictures of these sites when I'm out.
Seminole?
So that one was pretty cool.
That Seminole pipeline up in
I think it might have been. I don't remember exactly. You see the bypass leg.
Yep.
Runs around, all kinds of stuff. Just a cool picture. A multi-body valve, these are pipe pumps. Everybody knows what a pipe pump is? Do you know why we put pipe pumps on valves? why you order pipe pups on valves. Real simple. The seat for this valve, remember I showed that exploded drum, the seat's right there. When you go out and install valves in the field, do we have, or do you guys employ, you know, specialty certified welders that know how to weld around valves? The answer to that is no. You hire a contractor, some guy that he's welding on a pipeline today, he's welding on a ship tomorrow, he's out welding on a bulldozer next week. So what happens is this becomes, this is pretty thick material. If you overheat this, you can cook the seat. Okay? You get too much heat built up in the valve. So what happens is, we have the equipment, you'll see that today when we go on our shop tour, and we put a pipe pup, basically a pipe extension on the valve. We do the welding, we assume the responsibility, and that way when the welder's out here welding on the end of the pipe, he's got all the heat, he's got a heat sink there, plenty of room for the heat to escape out of the pipe before it gets back to the valve. So that's why a lot of people order them with pipe pups. About 80% of our welding valves, we ship them with pipe pups on. So if somebody says, you want pumps on this? Tell them I don't need any new pads. No, now you know what they're talking about, okay? Pipe pups. Question?